we're seeing here is that we're surrounding the Hodgkin cells by exhausted CD4 positive T cells, right? PD-1 positive T cells. We're getting those tumor-associated macrophages, right? They're PD-L1 positive. And then what we're seeing is that the CD8 positive T cells, those are the guys that are cytotoxic and might do some damage. They're being excluded. They're being kept out of the process. Same with the NK cells. We want them out because if they're out, then they're not suppressing the tumor. Now, we can also spin that the other way and say, if we wanted to treat these patients, how would we target these things? And I'm going to just think about it the other way. If we want Hodgkin, what would we do to target these things that are preventing us from listening to the or seeing the immune response? Another thing is just there is literally a swimming pool of cytokines that are released by the Hodgkin cells and by other cells that surround the Hodgkin cells, either causing immune suppression or causing cellular proliferation in either themselves or the Hodgkin cells. There's just a shopping list of immunosuppressive cytokines. And then there's a ton of other cytokines. You can see the other cytokines include things like IL-5 and IL-6, eosinophils, plasma cells, the kind of things that emit that stuff. So let's just talk briefly. This is a related but different topic about just proliferation and Hodgkin cells. We hidden from the immune system. Now we want to grow, right? So they can't just sit there. Clonality and accumulating mutations. Great. That's an interesting insight. I will look at that. Thank you, Swami. So again, some of the pathways that are really pushing the Hodgkin cells for proliferation, and we could see those, but a lot of the cases, JAK-STAT mutation activation is present in a lot of the cases, various different ways to get there. NF-kappa B activation in Hodgkin cells, Notch1, PI3K kinase and AKT pathway, and RAF-MAC pathway. Basically, the Hodgkin cell, if you look at it, pathway that, maybe not everything, but it's taken all these different pathways to provide for its own proliferation and survival. It's taken a myriad of approaches. It's almost as if it's under evolutionary pressure to say, should someone come along and try and block a pathway for my proliferation and survival, I'll just come up with another one, and another one, and another one, and another one. Dr. Mo makes the idea, at least Mick isn't involved. Yes, but I'll have something for you later, which of course is one of my faves. Back to a little history. So Reed-Sternberg cells were first illustrated and incorrectly identified by Greenfield in his paper. In 1898, Carl Sternberg published a paper in German that included their illustration of the cells along with a description of their pathology. Interestingly, however, Sternberg believed that Hodgkin was a form of tuberculosis, and 8 of 13 of Sternberg's cases had definite tuberculosis in them. In other words, they went back, they stained his cases for tuberculosis, and sure enough, they actually had tuberculosis in them. So what we probably can't appreciate here, and probably in some places in less developed nations, is that tuberculosis is endemic. How Hodgkin discovered this was not tuberculosis is kind of the amazing thing, because look at Sternberg's cases. He thought it was tuberculosis because even though the people had Hodgkin lymphoma, well, of course they had tuberculosis. Everybody had tuberculosis. Anybody with big lymph nodes back then probably had tuberculosis. So what we're seeing is that the endemic nature of tuberculosis in those days probably affected how this disease was considered and discovered and why everybody thought it was tuberculosis. Now, the clever medical student Dorothy Reed described the RS cells in her well-known paper on the pathologic changes in Hodgkin disease with a special reference to its relation to tuberculosis. She clearly described the Hodgkin cells and emphasized that it was not related to tuberculosis, and even did an animal inoculation to show that her cases did not develop tuberculosis and that this was something separate and different. So, when we have the European Sternberg-Reed cells and we have the American Reed-Sternberg cells, I think I'm going to lean towards the Reed-Sternberg because she didn't think it was tuberculosis. And just some history on Dorothy Reed Mendenhall. So she graduated from Smith College, spent a year at MIT. went to medical school at Hopkins in 1896, and she did an internship with William Osler, which I thought was really pretty awesome. She then did a pathology fellowship with was a pathology fellow with Henry William Welch. Did an internship in pediatrics in 1906. Married Charles Elwood Mendenhall. Had 4 children. One of them died. Returned to medicine in 1914 at University of Wisconsin. Took a little time off for the kids, and mostly spent most of her time in pediatric medicine. So her description of Hodgkin, I think, is the more impressive. Is that it was just kind of a summer project. You know, it was like kind of her medical student project, which I think is pretty awesome when you consider that that's how it came up and that she's sort of been immortalized for that. And just a real quick thing here, some actual images from her paper. This is from Dorothy Reed's paper, describing, drawing. So that's a gross image of a lymph node on the left. And then at the right, you can see things that, well, I could pretty much call some of those Reed-Sternberg cells. And just 1 second, Roberto. And even that one, if you look at the upper right on the far right-hand side, I'd say that's a pretty textbook Reed-Sternberg cell. Although, I gotta say, also kind of looks like a follicular dendritic cell to me. So I don't know. But anyway, so she described them. And I love the fact Roberto has made this comment. Is it possible that medical student Dorothy Reed had a mentor like Jeff Medeiros and suggested, why don't you report these cells I've been noticing? And I think that that's probably exactly the case. I think that we all, you know, almost everyone is tied to their mentors and how they've been sort of driven to do cool things. And so I think we should all, we'll take a moment and acknowledge that we've all had, hopefully acknowledge your mentors, thank them, send them a card. Jeff has mentored me. Peter Banks has mentored me. Roberto has mentored me. Tom Dutcher has mentored me. You know, those are people that I think have really made a difference in my career and helped me become a better pathologist. So a little more about proliferation and survival. So it turns out that eosinophils are recruited by Hodgkin cells by secreting IL-5, IL-9, these other factors. And guess what? They in turn can enhance the growth of the Hodgkin cells. Increased eosinophils is presumably associated with a poor prognosis. Now, this is somewhat controversial in the fact that, you know, yes, eosinophils are associated with prognosis, probably. When we see cases with a lot of eosinophils, it's probably worse prognosis. But to be honest, you know, this one, I think you could do it by AI and you could get a better result. I think historically, just the way we've done it's probably not so great. Mast cells, another guide. It turns out they produce tumor-promoting cytokines, and they're recruited by the Hodgkin cells as well. Increased mast cells is also associated with a poor prognosis. Interestingly, is that they're inversely correlated with macrophages. Now, that being said, you know, the macrophages are also associated with a poor prognosis. So I think it's probably just these guys are fighting it out. The reason why mast cells are always identified and recognized and have, if you look any of the literature, is because that in Germany, they would always do Giemsa stains instead of H&Es. And the Giemsa stains allow you to automatically see the mast cells, whereas in H&Es, we really don't see them without doing a special stain. Mast cells and eosinophils express CD30 ligand, so that's why they're sticking onto the Hodgkin cells. That's why they're heading towards them. So then there's the CD30 exosomes. What's interesting is, so you get these CD30 exosomes. They're sort of blobs of CD30 junk that are released by the surface of the Hodgkin cells, and they get internalized by fibroblasts, and that results in migration. And so that turns out that they're signaling for the eosinophils and the mast cells to come along and do that. So if you see sort of globby, not cellular staining for CD30, it may actually be exosomes. And if you could see it in fibroblasts, you wouldn't be surprised, but you're not going to diagnose those as Hodgkin cells. Plasma cells, it turns out, interestingly, I thought this was kind of cool. I had never really done any effort at noticing plasma cells, but it turns out that plasma cells correspond with B symptoms in Hodgkin. It's kind of an interesting thing. Correspond with advanced stage and correlate with eosinophil infiltration. So those background cells that we have that, you know, mostly, right, they're the background. They're part of the process. That's the thing. It's not a glitch. It's a feature. These guys are doing something in that process. So the overall survival is worth if you have greater than 10% plasma cells. I'm sure they'll sort of do a plasma cell count in a Hodgkin case. Interestingly, there's a study that just looked at it and just said that, by the way, IgG4 expression within the plasma cells doesn't really correspond with any of the features. So even if some of the plasma cells in a Hodgkin case are IgG4 positive, that doesn't really mean anything specific. It's just plasma cells overall, worse prognosis and symptoms. That's kind of interesting. So this is kind of an interesting thing. I just wanted to point out a few things. So the check marks are things we've already talked about, but just in general, you know, T regulatory cells have a favorable prognosis, but they tend to be downregulated. Cytotoxic T cells tend to be unfavorable, but in general, they're favorable because they tend to be sort of worse. I mean, they tend to be anti-tumor. NK cells generally are favorable, which means that that's why we want to sort of block them out of infiltrating. We already talked about B cells in general are favorable, but plasma cells are unfavorable. Remember, T regulatory cells are going to immunosuppress. The T helper cells are going to be exhausted, thereby sort of providing that protective coat around the Hodgkin cells. And that in general, cytotoxic anti-tumoral CD8 positive cells will be attacking the Hodgkin cells. Monocytes in general are unfavorable. And again, I probably suspect that has something to do with those myeloid-derived suppressor cells. Macrophages in general are unfavorable. Myeloid-derived suppressor cells unfavorable. Neutrophils unfavorable. Mast cells unfavorable. Eosinophils unfavorable. And dendritic cells. So that's follicular dendritic cells. You know, okay, fine, but I guess, you know, I would look at a very specific circumstance and say if you have sort of a Hodgkin that is interfollicular or follicular based that is sort of mimicking NLP, and you had more follicular dendritic cells, maybe you're actually looking at not cause and effect necessarily, but that one I'm a little bit dubious about. So again, a new picture. This one just highlighting that we're talking about the idea we've looked at the M2 type macrophages, those and the mast cells and the eosinophils and the PD-L1, PD-1 axis and the T regulatory cells and the immune exhaustion. All of this is taking, right? What we're doing is, remember, we have the tumor cell that is proliferating, but the tumor cell is also hiding from the immune system. But the tumor cell is creating an environment around itself that is keeping the rest of our immune system from actually attacking it. It is creating an impervious shell around it, an immune shell to prevent it from that. And so lymphocyte-rich classic, which have tons of TFH cells. Exactly, yes, Professor Moore, that's exactly it, the TFH cells. Remember, those are going to get exhausted by the whole PD-1, PD-L1 axis. Here's something Dr. Moe had mentioned earlier. I just wanted to take note. Of course, you can find B-cell clonality in Hodgkin cells, but you really have to work hard at it. Interestingly, I thought this was kind of cool, and this is back to Professor Moe was saying, is that immune suppression, yeah, okay, proliferation, JAK-STAT, NFK, P13 kinase, and then, but I also wanted to note that my old pal TP53 can be involved in Hodgkin cases, typically EBV negative, but that all the thing about TP53, which I appreciate, and is that once TP53 is involved, by the way, that's a picture of a P53 taken from just a random Hodgkin case. I think that is probably a mutation, but not necessarily. It may just be overexpression. But is that once P53 is involved, you have tons of genetic instability. And it might be that that's one of those events that's leading to all of these different pathways that are being activated in different ways that allow the tumor cell to survive. Yes, Professor, exactly. P53, Medeiros is saying that it's positive in RAS cells. The mutation's not so frequent, but again, if you look at the individual cells, overexpression is common, right? It's not wild type, it's overexpression. But that mutations, that's typically you would find it strongly and uniformly expressed in the Hodgkin cells. But again, I'm just saying is that once that happens, it leads to even more genetic instability in the cases. This is, again, a little history. I thought this was kind of cool because there's a few people whose names we might know. For one thing, Clive Taylor, still active in immunohistochemistry at USC, and Robert Lukes. So, remember the Lukes and Collins system. 1977, they published this paper, and I thought it was great. They didn't really know what Lacunar cells were, but they thought that it was a variant of the Reed-Sternberg cell, and that They thought the lineage is not exactly settled. However, there's been increasing evidence favoring a lymphocyte derivation. So I like the idea that they basically looked at these things. And if you look at their diagram, I think it's kind of fun because I think box A shows things that look like immunoblasts to me. Box B, I think we're clearly at a Hodgkin cell. And then boxes, C, probably maybe a lacunar cell, right? And then box D1 and D2 are clearly, these are Reed-Sternberg cells. So, you know, the lacunar cell, I think one of the great things about that is it was probably mostly an artifact of retraction artifacts, so that the cell would actually sort of shrink back because of the paraffin fixation, leaving this sort of lacoon or lake or pool around it. Okay, questions there. Hang on. Whoa. Let's back up. You guys getting moving too fast for me. Is there any decent study looking at the number of Hodgkin cells per high power field association prognosis, number of Hodgkin, the direct indicative turnover time? So that's a good question. I don't have the answer to that. I mean, I can tell you the idea. See, in some respects, maybe, but no. And I want to get to all of that in 1 second, because the idea of how many Hodgkin cells there are, if you say generically, if you said lymphocyte depleted has the most Hodgkin cells and it has the worst prognosis, you could kind of say that. You could then say, nodular sclerosis type 1 has fewest Hodgkin cells typically, or maybe even lymphocyte rich, and it's got the best prognosis. And then maybe NS2 has more, so maybe it's got a worse prognosis, which doesn't anymore. But let me get back to that. I want you to just think about that. P53 and NLP, I'm sure there is. I don't remember it offhand. And do we know where the distinctive look of the RS cell comes from? Is it incomplete mitosis or division? I don't have the answer to that. And Roberto has to go to faculty meeting. Yeah, okay. Yep. So anyway, we're going to continue on. Thanks, Roberto. Loved having you on board. Let's get back to our talk and move along. This is just kind of a cool thing because I just thought it was so fun. We don't do this anymore, but boy, I just think it's so neat. Phase microscopy of actual Hodgkin Reed-Sternberg cells. And what you see with phase microscopy of these is you'd see the little organelles. If you've never done it, it's really cool. You'd see the little organelles. And plastic reticulum and zoom around and then come back out. So I thought that was kind of cool. I also would like you to take note of something. This is for later purposes within the talk. Look at reference number 7. That is Medlar, EM, Interpretation of the Nature of Hodgkin's Disease, 1931. Okay, keep that one in mind. We're going to go back to that. This is just a little tiny sideline, and I just wanted to point out something too. This is a really nice paper. It's by Rebecca King from Mayo. She had a question about CLL with Reed-Sternberg-like cells versus Hodgkin transformation of CLL, and is this really, are they different? What's the story here? So in the upper right, what I have is I have a picture of a Reed-Sternberg cell in a CLL case. Okay, so that's, that would be, yeah, again, Mike, I'm going to get to that thing in a second. I think that's really a critical point, and it's what I want to get to. So if you look at the survival curve between a thing that is sort of a CLL that's Hodgkin-like, transformation versus a CLL with Reed-Sternberg cells, I don't see that the survival curves in this particular case are hugely different, although you could say the ones with the RS cells are a little bit worse, maybe. But what's interesting is here's another case on the right. That's a Hodgkin cell in a CLL. It turns out that if you take these patients, all of them, and if you treat them with Hodgkin-like therapy, they do a lot better overall than the ones that get treated with CLL therapy. So something about the Hodgkin therapy in patients that have ultimately that CLL event, even if it's just the Hodgkin-like cells, tend to have a better overall prognosis, which I think is kind of a cool, weird thing. So props to Rebecca for that. I think it's kind of interesting. And now we're getting to some important conclusions. And this is something that we need to go back to and address what Mike and some of the questions were before. So, as Professor Mo observed, there's not a single distinctive abnormality that characterizes Hodgkin, so comparable to like a Mick and Burkitt. That there's a huge number of pathways involved, so that they're all crazily involved, and that frankly, the Hodgkin cell has done everything in its power to come up with different pathways to take advantage of, to proliferate and grow, and you know, and the Hodgkin cells build their own microenvironment, right? Have I seen Mick on Hodgkin? Yeah, it's positive in most cases. It's expressed in Hodgkin cells frequently. I have a picture. I didn't use it because it's not really, you know, it's overexpressed. The tumor microenvironment will then feeds back on the Hodgkin cell itself and adds to its proliferation or survival. And then immune evasion and immune downregulation is critical to Hodgkin. But there's another key that I think that we need to get to, which is, and this is the remarkable thing, and this is something that I think Swami could speak to very well, Professor Iyer, is that, and yet, in spite of all this, in spite of this immensely clever disease that we have, that has done all these things to hide from the immune system, that has done all these things to find pathways to both increase its proliferation, but recruit these cells that improve its survival and proliferation, and that we can sit there and we can say, well, we can prognosticate, but that we have a really well-established therapy that's really, really super effective. So in other words, back to the idea of, yes, the Hodgkin cell, this tumor is a benchmark about biological complexity, and it's about how interesting and involved and weird and crazy you can get the biology of a tumor. And that this one's very distinctive, right? Because we really don't have a lot of tumors that are 99% background and 1% tumor cell. They're not. We have a few. I could name one. I think for example, hyaline vascular Castleman is a good example. There's some inflammatory sarcomas that have a lot of inflammatory cells and few tumor cells, but this is a distinctive process. And yet, we have a well-established therapy that cures most of the cases, which to me, I think is just amazing. It's amazing that we're able to short circuit this many different processes, this many different ABC lymphoma cells constitutively express MYC. Yeah, I know, but they overexpress MYC. That's wild type is not overexpressed. Professor Mo, you keep saying this stuff like this to me. No, they're not wild type. Anyway, so back to just the idea. This is just a sort of thematic overview. We're talking about immune evasion, lots of different processes, but basically the Hodgkin cell is hiding from the immune system. It is stripping its own fundamental nature as a B cell down to nothing so that it can hide from other immune responses. It's actively suppressing the immune system using those myeloid-derived suppressor cells, macrophages, T regulatory cells, the exhaustion of the T helper cells, immunosuppressive interleukin and cytokine production. And then finally, it is not only having mutated pathways that are adding proliferation, but it's recruiting cells that actually encourage its proliferation as well. Okay, so that's it. I'm going to say thank you. I have one slide after this, which is, so kind of a short talk, not super long, but wanted to thank Dr. Medeiros and Professor Biggs. Impact on TP53 mutation or overexpression in CHL versus wild type. I doubt that there is a specific impact that is discernible beyond standard therapies, which is to say that if you took 1,000 cases and found mutation, would it statistically impact the overall survival? Again, I doubt it in the face of current therapies. And unfortunately, what we're not going to do is not treat people just to find out if P53 works or not. And we end up being biased towards cases then that fail therapy. Those cases are probably genetically unstable. Then we have a bias of more likely to be mutated, and therefore, we build in biases into our system by looking at people that fail therapy. Here's my last slide, which I think is fun. Remember, he described the copper pennies and chromoblastomycosis, the so-called medlar bodies. Well, anyway, he thought that the RS cells are megakaryocytes derived from the bone marrow and regarded Hodgkin disease as a megakaryocytoma. So you can see on the left there that there's a megakaryocyte, and on the right is a unhappy-looking Hodgkin cell. Okay. With that, I'm going to stop. Back up one more time. Yeah, poor medlar. Kind of got it wrong, but okay. Sorry. Okay, what about nodular LP that also have few tumor cells compared to the background? Is it trying to copycat the real Hodgkin? I mean, I think it's a theme. I think it has a theme, but I think its theme is somewhat different because if you think about it, I mean, one of the things not. I think let me put it to you this way. I think that NLP has some of the tools in the toolkit that classic Hodgkin does, but not all of them, right? So, for example, it does have the PD-1, PD-L1 thing going on. So it's immune suppression, but it's still got all of its B cell markers. So it's not doing the same process of immune evasion. In some ways, I would say, and I know biologically this is a little bit cheap, but in some ways, I'd say that NLP is kind of less sophisticated in its processes than is classic Hodgkin lymphoma, right? So classic Hodgkin lymphoma has basically got all these things. It's got everything in the book to try and immune evade, immune suppress, and proliferate and survive. And NLP doesn't have some of those. It's missing a few of those. So I would say that, there's a theme, but I don't think they're exactly the same. So anyway, I appreciate your thanks. All good. By the way, if anybody has any more questions, I'll stay on for about 5 more minutes just to see, unless everybody signs off. Whatever you like. Yeah, poor medlar. Sorry, I'm sorry to be making fun of a scientist who I'm sure was doing this earnestly, but what are you going to do, right? Yay, megakaryocytoma. So I could have been talking on megakaryocytoma today. That could have been the talk. Who's cookies? Who identifies as cookies? That's funny. What do I think about the JAK2 altered ALCL? Are they the same as PAX5 negative CHL? I'm not sure how you mean that, Professor Mo. JAK-STAT pathway stuff. Are you suggesting that because they're JAK2 altered that they downregulate certain T cell associated markers? Cookies, yeah, but who are you, cookies? Okay, I'm not gonna read the paper in the middle of the lecture because I can't. One MGH just reported. I'm not going to read the paper in the middle of the thing. JAK2 rearrangements are recurrent CD30 positive systemic T cell lymphomas and anaplastic morphology. Okay, so what? Yeah, I mean, there's all kinds of genetic stuff that goes on in ALCL. That's a whole different story. I'm not shocked. I guess the question is they say systemic T cell CD30 positive systemic T cell lymphomas with anaplastic morphology. Do they mean ALCL, or are they suggesting that there's something different, Professor Mo? They want to call them something else. Okay, well, anyway, it looks like we're moving towards the end. No more questions or anything. Really lovely. Thank you guys for sharing your time with me. Appreciate it. I know your time is valuable, and I like sharing it with me. I really do hope that if you have any questions, you can certainly email me. If there's any issues or problems and you want to chat about it, happy to do that. But as always, it's been a pleasure, and we'll see you around. Okay, take care. Bye. And I'm going to sign off. So just so you know, I'm stopping sharing. And I'm leaving the talk unless, like I say, last thing. Okay, see you guys. Have a great week.
Sir, slide it to. Sir.